So yesterday I sort of did an informal definition of reference angles. So here's the formal definition. It's the acute angle, so that means it's an angle less than 90, formed by the terminal side of an angle and either the positive or the negative x-axis. So yesterday what did I say? Always make your triangle to the x-axis, right? So yesterday I just said, for the reference angle, I said, well, always make the triangle to the x-axis. And after all of you guys got that, it didn't seem to be a problem to work with it. But here's a little exercise in just then finding reference angles. So if you want to find the reference angle for 130, and I really recommend making sort of a sketch of this. So 130 would be like right around here-ish, right? Yes? We're good? And then that's 90, and that's 180. And you don't always need to put these numbers here, but for right now I'll put them there. So how far away am I from, which one am I interested in, the x-axis or the y-axis? X. So I don't even really care that that's 90 right now, because that's not what I'm concerned with. I'm concerned with the x-axis. So here's your reference angle. It would be the angle for that right triangle. So how far away am I from the x-axis? From 130 to 180 is how much? Well, then that would be your reference angle, wouldn't it? Are we okay with that? Yes? No? Seems a little quiet. Alright, we'll do it again. So 290. And once you get the hang of these, you can skip some things. So hopefully you sort of know now that that's 270 and this is 360. So 290, it's got to be pretty close to 270, right? So we're here. Now, John, which axis am I concerned about? X or Y again? Still X, right? Right. So I don't care about the 270 anymore. So I just do that to get an idea of where I am. There's my right angle. So what's the reference angle?
70.
70, because I'm 70 away from 360. Okay? Works with negative angles as well. So a negative 305, well, a negative 270 would be here, right? 3/4, and a negative 360 is here. So 305 would be where?
55 degrees.
You already gave me the reference angle. So pretty close to the middle, right? Yeah? Alright, so I'll just put it somewhere like here. So that's a negative 305. And then how far away are you from the x-axis? And you already said, well, that's 55 degrees. So notice that your reference angle is positive. Why does the reference angle sort of have to be positive if you can connect that with like sines, cosines, and tangents?
They're all positive in the first block.
That's true. And I didn't ask the question very well then. So, but even here, this is 70, right? So why does your reference angle always end up as a positive? So what I'm trying to draw the attention to here is the fact that we're dealing with triangles here, right? I made triangles. So the reference angle always should be a positive angle because you're trying to make a right triangle so that you can come up with some values like here and here. And based on that, you can find that one. And then now I could find sines, cosines, and tangents. Well, that's why you always need a positive angle. All right, last one, 415 degrees. Same spot, right? Because it's 360, and then how much past 360 is 415? 55. So those two are coterminal, right? Yes? That work one? So that one, and wow, that's ugly. That one. So coterminal. So that means they would have the same sides, cosines, and tangents, and reciprocals. Okay? Alright. So this is now a little bit new here. So you sort of knew that. So find the value of the sine and the tangent if you know that the cosine is a half, and then this part is important, and it is in quadrant 1. Alright, or quadrant 4, sorry. So what do you know about the cosine of an angle if it was just in right triangles? The cosine is what? It's probably me. What's your cosine? What's the definition for the cosine in a right triangle? Okay, I can take that. X over m, right? I was actually looking for SOHCAHTOA, so it would have been... Alright, and either one works. we will need x over m at some point. So what does that mean? Well, draw a picture. What quadrant am I? In quadrant 4. And so if I look at the cosine of theta and it says that that's a half, then what do I know? I know that my adjacent side is? Your adjacent side is?
1.
And your hypotenuse must be? 2. So here's your adjacent side. I'm going to label that as a 1. My hypotenuse is 2. Can you see how I can make a triangle based on that? Okay, so how do I find his y value? You know that 1 squared plus y squared is 2 squared. So y squared is 4 minus 1. So y would be the square root of 3. And if you'd recognized it as a 30, 60, 90, you could have already done that without it. So if you immediately saw that, well, that's 1, that's 2, this has to be the square root of 3, and recognize this, then that's your 60-degree angle, right? Yeah? Then you're fine. Okay, so how do you find your sine now? The sine would be what? Opposite over. Okay, and what am I forgetting? I'm in quadrant 4, the negative, right? And this is why I said the quadrant is important. This is a negative root 3, isn't it? And then the tangent would be what? A negative square root of 3 over, which is a negative square root of 3. Are we okay with this? So does it have to be a special triangle to make this work? I think we have another example. We have 2 more. So let's do the same thing. Find the value of the sine and the cosine if the tangent of theta is 4. Okay. I'm going to make this 4 over 1 because the tangent is supposed to be the ratio of which 2 sides?
Opposite of the
Yes. So what do I know about opposite and adjacent? I know that one of them is 4 and the other one is 1. Opposite being 4 and this one being 1. So a triangle looks a little more like this, right? Yes? There's the angle, which, do you know this triangle? Anybody? Is this a known special triangle? Nope. Can you still find the sines and the cosines? I think so. I just need to find out what the magnitude is, right?
And that's 1 plus.
Well, it would be 1 squared plus 4 squared, and then take the square root of that, right? So it's the square root of 17. Can you break down the square root of 17? No. So then leave it. Don't tell me that it's about 4.1. You know, don't get a calculator and tell me what it is. We want accurate values here. So the sine of theta is what?
4 over root 17.
4 over root 17. And the cosine of theta is?
1 over root 17.
Okay. Well, we already know what the tangent is, right? But we're not done. How do I know where I'm supposed to be? Why did I put it in quadrant 1? Because they're all positive, so it could be quadrant 1. What other quadrant could it be?
Quadrant 4.
Not 4.
Or 2.
Think about it. All students take calculus, right? All sine, tangent, and cosine. Where else is the tangent positive? Isn't it here? Didn't we do this in our notes yesterday? The last thing I did was tell you this little, hey, memorize this, all students take calculus, so that you can figure out where else the tangent or the sine or the cosine would be positive. That triangle could have been here. I could have had this triangle. This then would be a -1, and this would be a, is a -4 divided by -1 still 4? Yeah? Okay. Well, then we better give more answers here. The sine also could be what? negative 4 over the square root of 17. And the cosine also could have been what? What's the other cosine value that we could have had? Negative 1 over the square root of 17. Because it didn't tell me where I was, you need all 4 of these, okay? So this problem is a little annoying because they didn't tell me where I was. Remember when we did the first one, I said, hey, it's telling us we're in quadrant 4. That's important. Okay, so you need both sets. Alright, so these are easier problems, and then this is the last one. If it tells you that you're in quadrant 4, then that narrows it down, right? So you can draw your picture and you know you only get one picture. So what about your sine? Your sine is what usually? The sine of theta is 3 over 5. The 3 is which side? Which side is your sine in a triangle? Hello? I know these. Come on. You know them, but I need a little participation. So what do we know about the sine? What's the definition for the sine in the right triangle?
Set over hypotenuse.
Okay. Right, and the opposite is 3 and the hypotenuse is supposed to be 5. Okay, I have a problem with this particular question then. I'm in quadrant 4 and you're telling me this is supposed to be 3? That's a negative 3. Okay, so I'm not going to finish this problem. I don't know if I made this mistake when I made my notes or not, but this is impossible. Okay, so for the sake of time, I'm not going to finish this. We'll ask one more question then. What quadrant should I have been if the sign was positive? There are 2 other quadrants that I could have been in. I could have been in 1 and 2, right? So I should have either been over here in quadrant 1 or over here in quadrant 2. So this problem is just impossible because you're telling me that I need to be in the wrong quadrant. Okay.